Okay, in this video, we're going to actually create the logic model. We're going to use the drawing tools in PowerPoint to do this. We'll do it for the example of the Essex County gun buyback program, which we saw a video about in the last instructional video. So we're going to follow the advice that I gave there of starting by identifying the main outcome as a y variable and putting that on the right hand side, starting with a single x variable that represents the program on the left hand side, and then importantly we're going to add intervening variables um, which represent the way in which x influences y. They're the intervening processes, or the intermediate outcomes they're sometimes called, that show more specifically how the program achieves the outcome. Okay, so this will make more sense, the intervening variables, when you see them. So in PowerPoint, the way to draw a logic model is to use these shape tools. So under this insert tab, there's a shape, um, a set of shapes you can use. And there, in particular, we can use these ovals to represent variables and arrows to represent relationships. And we're also going to use the text box here to kind of label some of the relationships as being plus or minus. So let me start with an oval, and I'll put it over here. And I'm going to label this oval by just right-clicking on it and clicking on Edit Text. And this is going to be the outcome, right? The outcome the program seeks to achieve. Now, we can label it different things, but I think in the case of this program, a good label might be something like gun violence. The program is aimed at reducing gun violence. Okay, so that doesn't fit, so I'm going to have to, maybe I should shrink the text a bit. Also, it's that the colors are a bit light. So one of the things you can do is you can double click on this here, and then go to, we'll click on this and then go to Format. There's a set of formatting tools, and I'm going to go up here and just give it a more basic kind of shape, which is just sort of a black and white shape. I know that might seem a little boring, but it's easier to see. And I think, let's see, if I go here under Home, I can reduce the text size of that. Okay, maybe even a little bit more. Okay, yeah. Okay, so there I've got my outcome variable. Okay, now you can just copy this. Just click on it, right click, copy, and click someplace else and hit paste, and you generate a mirror copy. And that's a good way to kind of preserve the formatting. And then I'll come over here and I'll add the x variable, which is the advice here is to just label this as the program. So this is the gun buyback program. Uh, um, Maybe I'll just call it buyback program. Okay. Okay, so here's the most basic form of a logic model. We have the program here and the outcome. Gun buyback program, the outcome, gun violence. Now, okay, so I'm going to put an arrow between those just to show you how to draw the arrow, but also to think about the direction of that relationship. So I'll go here, I'll click on the arrow option, and I'll draw the arrow here. Now again, this template is drawing a very faint arrow, so I'm going to right click on this and format the shape, change the color to black, and change the line style to something a little bit bigger. Okay. Okay, now that's the maybe even make that a little bit bigger. 1.5. Okay. Okay, so there's the gun buyback program as the independent variable, gun violence as the dependent variable. Now let's think about the nature of the relationship. I'm going to use a text box here to try to label this as either being a positive or negative relationship. Now, so gun violence can go up and down. You can have more or less gun violence. What about the program, the buyback program? How can that be thought of as a variable? Well, what I would encourage you to think about is the notion of what's called a dummy variable. It's either you have a program or you don't have a program. And so the county can have a buyback program compared to a nearby county which doesn't have a buyback program. And if you think of the buyback program as having a buyback program as being coded 1 and not having a buyback program as being coded 0, then the program has a direction. You having the program is related to less gun violence, right? So more of a program, less gun violence. A lack of a program is associated with more gun violence, right? So having a program is associated with lower gun violence, and not having the program is associated with higher gun violence. That would be a negative relationship. So I'm going to type this in here as a negative relationship. I'm just going to move this text box a bit. You can kind of just move these things around. Okay, so that would be the simplest form of a logic model. So the program is associated with lower gun violence, right? So a negative relationship. Okay, so, but that's not too informative as a logic model. It might be accurate, but it's a little sparse, right? So what we're going to do now is add in some intervening variables. So I'm going to use, again, the copy trick to kind of stick in or create another oval with the same formatting. And I'm going to now think about an intervening variable. What's a possible intervening variable? So what does the buyback program do in order to reduce gun violence? Well, one answer is it reduces the number of guns in the community, right? The purpose of the gun buyback program is to scoop up a bunch of guns that would otherwise be in the community, and if you remove the guns, then you reduce the gun violence, right? So let me label this simply as number of guns, okay, in the community. Okay, now I'm going to go back and use arrows to connect these ideas, or connect. The program is going to reduce the number of guns. Now that's, again, I'm sorry for that formatting, but I'm going to click on this here. And then I'm going to go to home, and I'm just going to use this paintbrush to copy this there to that arrow. Okay, so you can use this under the home menu. You can use that paintbrush to kind of copy your formatting. Okay, so I'm going to do that. I'm going to go back to insert and put in another arrow that's going to connect the number of guns to the outcome. And again, I'm going to just click on this arrow, go to home, use the paintbrush to kind of copy the formatting. Okay, so that's an intervening variable, right? So the program leads to fewer guns, and guns are a factor in gun violence, and so that explains to some extent how the program is going to work. And in fact, that's sort of the main mechanism of the program, right? So here, let me just copy this text box, and I'm just going to paste it to create another text box. Now, the program has a negative relationship with the number of guns, right? So having a program leads to fewer guns. Not having a program leads to more guns. So similar to the gun violence link, the relationship between the program and the number of guns is also negative. But what about the next link? Hold on, let me just paste another one of these. What's the nature of this relationship? Now, we might think negative again, right? Because everything seems to be, sort of leading to reduced gun violence. But if we think about it, if we just isolate this relationship, more guns is related to what? More or less gun violence? More gun violence, right? More guns, more gun violence. Less guns, less gun violence. So that's a positive relationship, right? So this is not negative. This is positive. So I'm going to put in a positive sign here. Now that might seem counterintuitive at first if we look at the whole model, but it's not, because if we think of it, the program reduces the number of guns, but the number of guns is positively associated with the amount of gun violence. And in fact, if we multiply along this pathway, if we multiply negative times positive, right, we get negative, a negative relationship. And that's consistent with the original relationship of the program with gun violence, right? So the program, having the program reduces the number of guns. Lower number of guns equals lower gun violence. So this is consistent, right? A negative relationship here, a positive relationship here. By the way, if the original relationship between the program and the outcome is negative, then any of the pathways, when you multiply along the pathways, any of those multiplied effects should also be negative, right? So that's a good way to check the logic of what you've done. By the way, if you've drawn these arrows right, you can kind of move this around. I guess I haven't drawn the arrow right over here. I need to kind of connect it so it has a red dot. Oh, it's not working too well. Okay. Let's see, does that do it? No. Okay. Well, there's a way to let me cut this arrow out. There's a way to kind of anchor these arrows so that they move when you move the variables. That turns out to be helpful later on as you start to kind of, as the diagram gets more complex. Let me just try to redo this one. I'll draw it here until I see the red dot there. Okay, and then I'll copy this format here. Let's see now if I've managed to do this right. Yeah, there. Okay, see now, see how the arrow stays. I can move this all around, right? And the arrow stays. Now that turns out to be useful when you have more than one intervening variable and you need to kind of move things around.